Hey there, and welcome to this explainer. We live in this incredibly connected world, but have you ever stopped and thought about who actually holds the keys to your digital life in our modern smart cities? Today, we're unpacking some seriously groundbreaking research that shows exactly how citizens can finally take back control of their digital data from big tech. Okay, let's just dive right into this. Here is our mental roadmap for today. First, we'll hit the smart city data trap. Second, taking back your identity. Third, the Santa Rosa pilot. Fourth, under the hood. Fifth, speed versus true decentralization. And finally, number 6, the future of digital ID. All right, part 1, the smart city data trap. We really need to talk about the hidden costs of all these connected devices. Think about your days so far. I want to ask you directly, how many times have you blindly clicked sign in with Google or sign in with Facebook today just to access some digital service? Honestly, if you're like most of us, it's basically a reflex at this point. We rely so heavily on these centralized platforms to prove who we are online. It's incredibly convenient, sure, but that convenience has a massive hidden price tag. See, when we use these digital services in our fast-growing smart cities, whether it's urban transportation, local government apps, or healthcare, we're pretty much forced to hand over our personal data to third-party systems. Big tech platforms act as these giant centralized authorities, essentially hoarding all the data generated by this infrastructure. And the research highlights a major risk here. This total lack of control lets service providers exploit your data to generate deep insights into your consumption habits, what you do for fun, and even your political opinions. It's a massive vulnerability for everyday citizens. Which brings us to part 2, taking back your identity, and the massive paradigm shift we are about to see. So the alternative to this data hoarding is something called self-sovereign identity, or just SSI for short. Basically, it's a model where individuals retain direct control over their digital credentials. You get to decide exactly when and with whom you share your information. Think of it like a physical wallet, but entirely digital. In your actual physical wallet, you hold your ID cards, your gym membership, your driver's license. A massive tech corporation doesn't hold your physical wallet for you, right? Well, SSI brings that exact same level of direct personal control into the digital world. So, the crucial point is how this actually works in practice. SSI uses things called decentralized identifiers, or DIDs, and verifiable credentials to validate who you are without exposing unnecessary personal info. It relies heavily on a brilliant concept called selective disclosure, or data minimization. Let's say you're going to a club. Right now, you hand the bouncer your entire ID. You're showing them your home address, your exact height, your full name, frankly, way more than they need to know just to prove you're over 18. But with selective disclosure, your digital wallet just generates a simple cryptographic proof that says, yes, this person was born before this specific year. The bouncer gets exactly what they need, and your private details stay completely private. All right, part 3, the Santa Rosa pilot. Let's take all this theory and see it tested in reality. So the Municipality of Santa Rosa down in Brazil actually ran a pilot project using this exact self-sovereign identity framework. Their goal was to manage citizen identification so people could access a repository of environmental data generated by the smart city itself. They wanted to ensure secure access to these urban digital services while strictly preserving user privacy. Plus, they wanted to increase the resilience of the entire system. This was a direct, practical, real-world test of connecting human citizens with smart city infrastructure, completely cutting out the big tech middleman. Now, to make this actually work for everyday citizens, the researchers developed a mobile app. And the really brilliant thing about this app is that it completely hides all the incredibly complex cryptography happening in the background. The research specifically points out that a huge hurdle for SSI adoption is usability. You can't expect non-experts to manage complex encryption keys. By using an intuitive smartphone app, they proved that SSI absolutely must be treated as a socio-technical system. It has to balance robust security with social acceptance and seamless usability. Because honestly, if it's too hard to use, people just won't use it. Moving on to part 4, under the hood. Let's talk about the 2 blockchains that made this happen. And this brilliantly illustrates the back-end architecture of the Santa Rosa project. The researchers actually decided to integrate 2 completely different decentralized identity systems in parallel, so they could compare them side by side, Trustchain and Hyperledger Indy. Right there in the middle is the proxy server. That's the main integration point. It's a REST API that bridges the decentralized identity system on one side with the smart city's sensor database on the other. Trustchain anchors its data on a massive public network, specifically the Bitcoin blockchain via the Ion network, while Hyperledger Indy acts as a more controlled, permissioned ledger.
So when a citizen actually wants to access that environmental data, it triggers this really neat four-stage credential-based authentication flow. Step 1 is presentation. The mobile app sends a verifiable presentation containing only the necessary attributes to the API. Step 2 is verification. The API queries the resolver, like Trustchain or Indy, to get the DID document and verify that the credentials haven't been revoked. Step 3 is authorization. The system checks the specific access policies for roles and scope. And finally, Step 4, delivery. The API queries the sensor database and returns only the authorized data back to the user. It's clean, it's highly secure, and it's incredibly private.
Which brings us to part 5, speed versus true decentralization. Let's look at the architectural trade-offs they found.
This pilot revealed a classic technology trade-off. On one hand, you have Hyperledger Indy. Because it's a permissioned ledger, it was incredibly fast and predictable. Creating an identity took only about 500 milliseconds, barely a blink. On the flip side, you have Trustchain. Trustchain anchors identifiers on the massive public Bitcoin blockchain, which gives you unparalleled immutability and true global decentralization. But because it relies on Bitcoin, final publication averages around 10 minutes, and you have to deal with transaction fees. So it basically boils down to a choice between lightning speed and absolute public immutability. Now, what's absolutely fascinating here is the verification time at the very bottom. You can see the setup time for Trustchain takes days compared to Indy's hours, and that final creation time is way longer. But look at the verification time. When the system actually needs to read or verify the data, both systems perform spectacularly well. Indy verifies in about 150 milliseconds, and Trustchain takes just 50 to 300 milliseconds. To put that into perspective, this proves that even when you are using a globally distributed public blockchain, day-to-day read operations for citizens just trying to access city services remain incredibly efficient. And finally, part 6, the future of digital ID. Where do smart cities go from here? Ultimately, the researchers concluded that there is no magic silver bullet here. Context-sensitive architectural choices are required. If a city needs free, instant onboarding, a permissioned ledger like Indy might be best. If they need global immutability without relying on any sort of consortium, Trustchain is the way to go, even with the latency. Moving forward, the researchers emphasize that we absolutely must treat these as socio-technical systems, evaluate them on a much larger scale to really stress test that latency. And crucially, we have to start preparing for emerging threats by examining quantum-resistant cryptography. The tech works today, now it's all about scaling it securely for tomorrow. So, wrapping this all up, it comes right back to you, the citizen. Self-sovereign identity is not just some fancy technological upgrade, it is a fundamental shift in digital power. The tools to eliminate centralized data hoarding actually exist today, as proven right there in Santa Rosa. So I want to leave you with this one crucial question to chew on. Will you control your data in the smart cities of tomorrow, or will your data control you? Thanks so much for joining me on this explainer. I really hope this sparked your curiosity, and until next time, keep exploring.